Hello everyone, I hope you're doing great, and it's been a long time since I did the last video on YouTube, and that's because I had exams in my university which I finished now, and I've got some more time to do videos on the channel. So if you remember, in the previous video we built dual regulated power supply. We hand soldered some components on a prototype PCB board, and we did some measurements and testing, and I thought it would be a good idea to do PCB design using Altium Designer and send the files to JLCPCB to do the board. So in this video we're going to do a PCB overview of the first boards I've built, and I got them manufactured by JLCPCB. The boards, as you see, were pretty simple boards, and that's because that's the first time I'm sending a design for manufacturing, and I want to keep it simple, so in case I mess up, it's not a huge deal. But as you are going to see at the end, everything turned out pretty nice. Everything worked great, so I'm definitely going to do some more complicated PC boards in the future, so stay tuned for that. I will also point out some of the mistakes I did on the prototype board, which caused shorts and caused the boards to fail. We're also gonna give a quick look at the Altium Designer project. I'm gonna hand solder the components and give at the end the board a final test to see everything is working as intended. So before we get into the video, I want to let you guys know that if you like this kind of videos, please give me a sub and like the video, because it helps me a lot and it helps the channel grow and motivates me to do more videos like this. Also, I want to point out that all the files of the project are down in the description in my GitHub account, so if you want to check the project and build it, you can find the files down below. But double check everything, and in case something doesn't work, I'm not responsible, and you have to do everything at your own risk. So let's get into the video. Starting with the overview, the PCBs arrived in this box. The packaging is pretty decent, and as I opened the box, I saw some foam here inside with some stickers, and the boards are also packed again with some additional foam. The package arrived pretty quickly at I think it was about 2 weeks. Less than 2 weeks, which is actually pretty fast, and the process of ordering those PCBs was pretty straightforward. I actually exported the Gerber files from Altium Designer, and I uploaded to the website, and I did some tweaking, like what materials I could use and stuff. I didn't change anything in those ordering options, and I paid and I ordered those boards. Actually, those weeks there was a detailed ordering states. The manufacturing process was pretty detailed, and it was showing on which stage of manufacturing the boards are. So the boards are here, and as we see here, I received 5 boards, and as I see, they turn out pretty small. Here are the boards as they were on the Altium Designer program, and they turned out pretty nice. So we're gonna head over to Altium Designer and make a quick overview on the design. As you see, the board is pretty simple. We've got ground plane at the bottom, and we've got on the top layer the power layer, and I actually separated the voltage lanes, the voltage planes as they were on the schematic, with the 15 volts, the VCC, and the ground plane. I have the ground plane on the middle, and I've got the regulated voltage coming in a separate plane, both on the positive and the negative voltage, and I've got the unregulated voltage coming from the big capacitors into separate plane at those two pins. So reviewing the circuits that I did over and over again, and also watching and reviewing the PCB that I did on the previous video with the 15 volts regulated power supply, I noticed some problems, and I did some mistakes. The first mistake that I did was that I completely miscalculated the diode current capabilities that the diodes that I used on the board, on the prototype boards, and I actually miscalculated also the resistors on the design, and the diodes that I used were rated for 1 amperes of current, and when I had those big capacitors, the 10,000 microfarad capacitors, when these capacitors are discharged, they're actually like short circuits, and they consume a lot of current through the AC input, and this current was was a lot for some milliseconds that blew my diodes, my input diodes, and created a short circuit that also blew my regs, my positive, I think the positive reg. So this was one of the mistakes that I did. And the other mistake that I did was on the design. I used 1K resistors, one at 0.27 watts power, which is actually pretty small power, and at 20 volts I calculated that you have to use higher than 1.6K resistors in order to have 0.25 watts of power dissipations. So on this board we're gonna use 5K resistors for discharge resistors. And I want to say that I'm really sorry about the mistakes that I did, and every time we watch circuits on videos, you have to double check for the components that are used, and also you have to use proper components for your current application. So some suggestions that I want to make: actually, when you use the circuits, to use on the AC input some kind of fuse that will pop in case something shorts in the circuit. So we're gonna move over to solder all the components and check how the board turned out, and we're gonna do the testing. So this is the final result of the PCB. As you see, I added some heatsinks here at the regulators. I also added the terminals and the big capacitors, and I'm gonna add the diodes. I don't have the proper diodes at the moment, but I'm gonna add them. So I'm really happy how it turned out. It turned out pretty nice and as expected. So I'm gonna add the proper diodes, and we're gonna check the voltages and the final result. So as you see here, I've put it the new diodes, and I just want to point out that look at the difference of the diode that I use now and the diode that I used before. And I think that we've got a lot of headroom with those diodes because are rated for 3 amperes and this was rated for 1 ampere, and that was probably the cause that made the prototype board to fail, to not work. So let's connect the transformer into the board and check if all the voltages are right. As you see, I've connected the transformer to the board in the inputs, and we're gonna plug the transformer and see if everything works fine. We're gonna check for some voltages. We should have minus 14, which is nice. We have to have minus 20, which is the unregulated rail, and we should have the same but plus 15, there we go, plus 15, and plus 20, which is the unregulated positive voltage. So as you see here, everything works as intended. We've got big diodes this time, and I don't think this is gonna cause any problem with the current capabilities of this board. So everything turned out pretty nice, and that's the video. Hope you like it, and we're gonna definitely have videos like this in the future, so stay tuned. Thanks for watching, thanks for tuning into the video, and I'm gonna see you in another project.